Welcome to qnawire.
Here we have a wheel with a small inner radius and a larger outer radius, not drawn to scale here, of course. The inner radius is 40 millimeters, the outer radius is 90 millimeters. And there are two boards sliding, one at point B on the bottom of the smaller cylinder here, moving to the left at 200 millimeters per second, and one at the top, moving to the right at point A here at 60 millimeters per second, so a little bit smaller. And we want to find the velocities of point P and of point O. So point P, we know will have to be moving at a direction up and to the left in this case, because it has to be 90 degrees away from the line CP. And point O then we'll have to be moving directly to the left in the same direction as B is moving. Okay, so what we need to do then is figure out what that angular velocity is, and we can do that by saying omega should equal VA over the distance AC, but this also has to equal VB over the distance BC. But we don't know AC or BC yet. We do know that AC plus BC should equal little r plus big R, because we go across one radius between O and A, so that's big R, and then plus this distance OB here. So we know that AC plus BC should equal little r plus big R, which is 130 millimeters. From our equation for omega here, we can find that we have 60 over AC equals 200 over BC, or AC equals 3/10 BC. So we can put that into our equation for AC plus BC. So that gives us 13/10 BC equals 130 millimeters. In other words, BC must be 100 millimeters. In that case, then AC, which is 3/10 of that, must be 30 millimeters. So this point C must be much closer to A than it is to B. So the next step then is to calculate the velocity of the center of the wheels, VO, which would just be omega times the distance OC. Well, this distance OC is fairly easy to calculate. It'll just be the distance BC minus the distance BO. We also need to actually calculate what omega is here, which I just realized I had not written down for us or wrote out. So we have VA is 60 millimeters per second divided by AC, which is 30. So that gives us 2 radians per second for omega. So this gives us a 2 for the velocity of point O. Omega is 2. OC is the distance BC, which is 100, minus the BO, which is 40, which gives us 60. So this gives us a 120 millimeters per second for the velocity of O, and this will be to the left. So I'll just draw an arrow here. Next, we will have to figure out the velocity of point P. This one will be a little bit more complicated. We'll have to use some geometry here. So we'll have to calculate this distance OC, which we just found was 60. But we'll also need this distance OP. And then we'll use the Pythagorean theorem to find the distance CP. Luckily for us, OP is just the radius of the larger circle, so that's 90 millimeters. So we have that the velocity of point P is omega, which will be the same as it was before, times the square root of OC squared plus OP squared. Again, OC we found to be 60 millimeters, and OP is 90 millimeters. And when we put all these in and multiply them out, we get a velocity of 216.3 millimeters per second. And this will be up and to the left, perpendicular to this line CP here.